Well, first of all, what is a chemical bond? A chemical bond is an interaction that holds atoms or ions together. But first of all, we must know what a Lewis dot diagram is. This is an example. It only shows valence electrons and the element symbol itself. And another important thing, 8 valence electrons equals a happy atom. And all these chemical bonds fall into different categories. Well, one of these is called ionic bonds. And ionic bonds, for example, we have Li here. And Li has 1 valence electron according to its placement, and we're combining it with F, which has 7 valence electrons. When they are combined, as you can see here, when they are combined, the electron moves, creating both happy. Well, electrons are negatively charged, so you can see the Li lost while the F gained an electron. And losing is positive charge because positive overpowers, and gaining an electron is a negative charge because it adds to the negative, and we call these catons and anions. The characteristic properties are high melting points, high boiling points, and more, and forming of compound formulas now. Alright, so we have K and we want to combine with Cl. K has +1 while Cl has -1. This only happens metal and non-metal. As you can see, K is +1. That means that it is 1 more to it, and Cl is -1, so it needs 1 more to have a complete outer shell. And when you combine 1 minus 1, obviously equals 0. And when they are combined, it's just KCl. Ca, another example, and Br. Well, first of all, Ca is +2, and Br is -1. When they combine, they don't equal 0. +2 minus 1 does not equal 0. So how do you solve this? You use the crisscross method. You take the 2, you put it under Br, and you take the 1 and put it under Ca. And it should look like this to create ionic compound formula. 2 times -1, which is Br, and this is the way you can check it, which leads to -2. Now you take the other side, 1 times 2 equals 2, so at the end of it all, 2 minus 2 equals 0. So that's how you can prove your ionic compound is true. Now, when it comes to naming ionic compounds, they must have a suffix at the last element. For an example, Mg and F2. Mg, which equals magnesium, fluoride. Notice the IDE. And now, that's basically much it. Now we move on to covalent bond. And covalent bonds is between nonmetal and a nonmetal being combined together. Unlike ionic bond, however, electrons are not gained or lose. Nope. Instead, they are shared by the atoms themselves. For example, an oxygen atom right here has 1, 2, 3, 4, 5, 6 valence electrons. and when we are combining it with one hydrogen, the hydrogen forms along with the H, and as you can see, they share a pair. The hydrogen shares to create a full outer inner circle, and the oxygen uses one of the hydrogen's valence electrons to try to make it. However, we're still missing one in order for oxygen to be happy. Exactly. So we add another hydrogen, and therefore those are covalent bonds taking place because they are being shared, and it will form H2O. Another way of doing this is also the crisscross method that we use for ionic compounds. We move it to the bottom. 1 and 2, we move them to the bottom, and this should still create H2O, which is a water molecule, and that's important because only covalent bonds form water molecules. Now to the characteristic properties. They have low melting points, low boiling points, usually gases and liquids, and do not conduct electricity well. And when we name these molecules or covalent bonds, there are rules. There must be mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. But however, there still has to be the suffix of ide at the end of the second word. Taken for example H2O. H2O equals dihydrogen monoxide. As you can see, the di represents the 2 and mono or mon represents the 1 oxygen, and there's still the ide at the end. Now we move on to BF2, and BF2 will equal boron difluoride. Notice the ide at the end, and the di represents the 2. However, boron does not have a prefix because if it's just one boron, then it's just boron. Now moving on last, metallic bonds. The last of 3 categories. It combines metal and metal, and is formed by the attraction of between positively charged metal ions and the electrons around the ions. And the energy levels collapse into one another, and this allows the electrons to flow freely throughout the metal and around the positive ions. At the same time, it goes non-stop, canceling out the positive ion charges to make the metal still and combine. And now we move on to characteristic properties. First of all, it allows the conduction of electricity, because when it is plugged into an outlet, the electrons flow past the ion and electricity goes through the wire into like a light bulb or something and generates light. And the other characteristic property is that it can be rearranged easily, such as because of how the electrons are canceling the charges, it can make it stronger, so it can be moved around and reshaped easier without breaking. And ductivity and malleability sort of describe the ability to reshape for metallic bonds. But not only that, but also they are really useful to day-to-day uses today, because many require like spoons, bent metals, and things such as wires to conduct electricity in thin strips. And this helps us today in our civilization really well because it's more convenient, simpler, smaller, cheaper, and it can do many things.